Hey everyone, it's Ben from Board to Bits, and welcome to part 5 of our series on making a procedural mesh through scripting in Unity. Now that we understand how vertices are going to influence our mesh, we can start creating a procedural algorithm to position our vertices rather than just hard coding where they're going to appear. Procedural meshes typically appear in 3 structures: grids, cubes, which are also called voxels, and extrusions. Today we're going to be focusing on grids. Grids are two-dimensional arrays of vertices, which will form a plane of cells in the shape of quads, triangles, or even sometimes hexagons. Some things we're going to want to be able to control in our grid are the size of each cell, the positioning of each cell, as well as the positioning of the grid in the world space, and the number of cells that are in our grid, possibly in 2 separate dimensions if we want to have a different height and width. We're going to assume that we want our grid on a single plane for right now so that we don't have to worry about rotations as well. So to get started here, I'm actually going to do a little bit of cleanup. I'm going to create a folder and I'm going to say old meshes, and I'm going to put all of this in there. We don't need any of this information right now. I'm going to create a new scene. I'm going to save this scene as grid mesh, and I'm going to create a new C# script. I'm going to call this Procedural Grid. We can open this up in MonoDevelop. And let me zoom in a little bit here. And similar to our previous procedural mesh class that we had, I'm going to require a couple components. Require component type of mesh filter, as well as type of mesh renderer. And a handy little tip I found is that you can actually keep all of this on one line like this, just separating out each type by a comma, which helps you save a little bit of space up in your header area. Now down here, we're going to want our variables that we had last time are mesh, called mesh. We're going to have a vector3 array called vertices, and an int array called triangles for keeping track of the information in our mesh. In addition, I'm going to put in a few public variables that are going to be kind of our setting. We'll actually call this grid settings. We're going to have a public float called cell size. We're going to have a public vector3 called grid offset. That's going to determine where the kind of the initial origin of the grid appears. And finally, we're going to have an int called grid size. Right now we're going to assume that we want our width and our height to be the same. If you would wanted to do different values for those two, you could say something like grid size X and grid size Y. In addition, we're going to need something similar to what we had before. We're going to change this to an awake function. And I'm going to set mesh equal to get component mesh filter dot mesh. And then we're going to delete the update function. I'm actually going to put in a new start function here, if I can type properly. And in here we're going to call 2 methods that we're going to create. The first one's going to be called make procedural grid, and the second is going to be called update mesh. Update mesh is going to reflect kind of what we did in our previous script, where we are going to set the vertices, set the triangles, and recalculate our normals. We're going to start by clearing the mesh just in case there is any existing information in there. And then we'll say mesh.vertices equals our vertices array, mesh.triangles equals triangles, and mesh.recalculate normals. You could also just have copied this from the previous script, but I figure it's good to kind of go through it again and remember the different things that we have to put in. Now, our making a procedural grid is going to be where we're populating this information, creating these arrays and populating them, but we're going to do it a little bit differently than we did last time. Last time we just said, vertices is going to be this array with these 4 points in it, and that's, all that we can ever do. Now we're going to start saying, okay, we're going to set a size for this array, and then we're going to start populating this with information based on the settings we have. So, in order to start doing that, I'm going to create this method, make procedural grid. It's going to take no parameters. And in here, we are going to start by setting our array sizes. Then I'm going to actually do a quick other piece of math, which is going to be to set what I'm going to call our vertex offset. And that's going to be, because we don't have a permanent size to our cells. Our cells could be, we're going to be able to adjust the size of them. That's going to affect how our vertices are positioned. And so we're going to do a little bit of math for that. And then finally, we're going to populate the vertices and triangles arrays. So setting the array sizes, right now, for our very first grid, we're just going to kind of assume, for simplicity's sake, that we just have a size of 1, or rather a grid size of 1. So we've only got one cell in this grid. Once we start creating more cells, we're going to have to kind of go into a for loop to do it properly. But this is just really to show kind of the bare basics of creating this quad in this more procedural format. So in order to do that, we know that a quad requires 4 vertices. So we can set our vertices equal to a new vector 3 with a size of 4. Likewise, triangles, we know there are 2 triangles, and therefore there are going to be 6 total triangles indices we need. So I'm going to say new int 6. Now the vertex offset, like I said, is going to be based on our cell size. How we had our cells built in our original mesh was that there was one corner was on the origin 0, 0, 0, and then the other 4 corners, or other 3 corners, I should say, are on 1, 0, 1, 1, and 0, 1, respectively, which worked okay for showing how a quad works. But really, when we start doing procedural work in that, it's really nicer to have things like our quads in different shapes kind of centered on the origin rather than having the origin on one corner of them. So what I'm going to do instead is I'm going to kind of shift these half the size, both to the left and down, or back, if you will, so that that's going to be centered on that, which means that what we're really dealing with is half of the cell size. So each vertex is going to be half the cell size away in 2 directions. So rather than dividing it by 2 every single time or multiplying it by half every single time we're calculating it, I'm just going to set a float right here. I'm going to call this vertex offset. And that's going to be equal to cell size times 0.5. You could say divide by 2, however, dividing is actually a little bit more of an expensive thing to do, so when you can, it's always a good idea to multiply if you can. Sometimes you can't, in which case it's a good idea to at least limit your division to as few times as possible. So for example, if for some reason we had to divide this right here, it's better that we're doing it here rather than every single time we set a vertex. Speaking of setting vertices, we can do that now. So vertices, we're going to have 4 vertices we need to set. And they're the indexes of our array. So vertices 0, 1, 2, and 3. Vertices 0 is going to be, remembering how our previous one was, we had the 0, 0, 0, 1, and then 1, 0 was the first triangle. So, like I said, we're kind of subtracting half from each of those. So subtracting half from 0, 0 is going to be negative half, negative half. And what that looks like is negative vertex offset, 0 for the y, and negative vertex offset. The next one, how we had it originally, was that the z-axis was going to be 1. The x was still 0. So for the x-axis, we're subtracting the vertex offset from 0, so that's still the negative, but subtracting it from 1 would have been a positive half. I'll show it here in its new vector 3. So x is still negative, vertex offset, still 0 for y, and then our z is now going to be positive because it's going, beyond or above the origin. So we're going to just say vertex offset. I don't know why it decides to put a space on some occasions but not others. Now, vertices 2 is exactly the opposite. Now the x value is going to be positive, but the y value will be negative. Vertex offset for x, and negative vertex offset for z. Let me just clean this up a little bit here. There we go. And finally, our very last one, vertices 3, is going to be positive on both the x and the z. Zero and positive vertex offset. Fortunately, MonoDevelop keeps on wanting to clean this up for me and therefore actually makes it a little bit messier. So there we go. Those are our vertices now. And like I say, we're creating these procedurally now based on the information that we're putting in here rather than hard coding a specific setup. Now it is kind of a little bit still hard coded in that we're establishing that we only want it on the x and z axes, but it's still a lot more fluid than it would have been if we were saying that this has to be -1, this has to be 0, etc., etc. Now triangles are still going to work the same way. Our triangles are still going to want to be 0, 1, and 2, and then 2, 1, 3 in order to properly go counterclockwise around both triangles. So for those are going to be a little bit more hard-coded, but that's just really because that's the pattern right now of the quad. Eventually we will actually add a little bit of dynamic content to it as well when we start adding counts to our, like having more quads in our grid. But for now, we're just going to say triangles 0 equals 0, triangles 1 equals 1, triangles 2 equals 2, triangles 3 also equals 2, triangles 4 equals 1 again, and triangles 5 equals 3. And obviously 0 refers to the 0 vertex here, 1 refers to the 1 vertex here, so on and so forth. Now we'll notice that some of these are actually the same. Triangles 2 and 3 have the same value. What we can actually do to save a little bit of space is we can cut that and paste it into here like this and say triangle 2 is going to equal triangle 3, which is going to equal 2. And that will actually pass this 2 reference to number 3 and this 2 value to triangles 3 and triangles 2. We can do the same thing with triangles 4, so these both equal 1. It's not something you have to do, it's just really a little bit of sort of syntactic sugar to make your scripts a little bit shorter. And with that, we've actually got our initial quad built. We can save this, jump back over to Unity. I'm going to create a new empty game object. That's not on the origin right now, so we're going to reset this. And I'm going to add our new procedural grid script. It automatically adds the mesh filter and renderer, and we see now that we have this cell size here. So I'm going to make this equal to 1. I should actually probably, before I forget, I'm going to go back in here. It's a good idea. Make that equal to 1 to start. Otherwise, you might, kind of start your program and wonder why no cells are appearing. So that won't automatically change it here for you now if this has already been populated, so make sure you've got a size in there. and when we hit play, we see that the quad appears. Now it doesn't have a material either because we didn't put one on there. I'll add just the default diffuse material there. And so now we see it with the quads appearing properly. Now, that's at cell size 1, looks very similar to what we did originally, except it's now shifted to the origin rather than into this corner. If I were to up this, like say to something like 2.5, we see that it changes for us and it changes the size of the cell, which is exactly what we want. It's now reflecting the information we're putting into it rather than just having this permanent size. Now, grid offset is not going to change for us yet. If I were to make x something like 0.75 here, it's not going to actually move because we're not implementing that variable yet. We can do that very quickly, though, because what we have here are vector 3's that are our vertex positions, and our offset is a vector 3. We can simply add those together. So right down here we can say plus grid offset, and then I'm just going to copy and paste this, save that, and now what we'll see, we've got that plus 0.75, is that our grid has moved, our quad rather, has indeed moved over 3/4 of a unit. And that's, again, reflecting that we've added that shift to each vertex's position. Now, right now, it's not super useful. In fact, we would probably usually want our first quad to always appear at the origin. But that is going to become much more useful once we start adding more quads, and I want to be able to kind of shift each quad based on its position in our full grid. But we'll get into that and adding more quads in our next video. In the meantime, thanks for watching, and I'll see you next time.